Welcome to the AWS Certified Cloud Practitioner Prepcast, where we guide you through everything you need to know for your certification exam. Whether you're just starting or looking to refine your knowledge, this course will set you up for success. Brought to you by baremetalcyber.com. Let's get started. Encryption in AWS is not just a technical feature, but a foundational principle of cloud security. The goals of encryption are threefold: to ensure confidentiality, so only authorized parties can read data; to preserve integrity, so information cannot be tampered with unnoticed; and to support compliance, meeting legal and industry requirements that demand sensitive data be protected. Without encryption, data is exposed both when stored and when transmitted. For learners, it helps to imagine encryption as both the lock on a vault and the seal on a letter. It protects contents at rest and in motion, reassuring owners, regulators, and customers that data is safe from prying eyes. AWS Key Management Service, or KMS, is the centerpiece of encryption at rest. Its purpose is to centralize key management across AWS, avoiding the chaos of scattered, ad hoc key storage. Instead of each service inventing its own key scheme, KMS provides a consistent system. This matters because encryption is only as strong as the keys that control it. If keys are lost, stolen, or mismanaged, the data they protect becomes vulnerable. Beginners should view KMS as the master key ring in a secure office. It controls access to every locked drawer and file cabinet, but it must itself be carefully guarded. KMS supports two types of keys: symmetric and asymmetric. Symmetric keys are the most common. The same key is used to encrypt and decrypt data, much like a single physical key that locks and unlocks a door. Asymmetric keys use a key pair, a public key for encryption and a private key for decryption, or vice versa for signing. This is useful in scenarios such as digital signatures and secure communications, where you don't want to share the decryption key. For learners, symmetric keys are simpler and broadly supported across AWS services, while asymmetric keys solve more specialized use cases that require cryptographic flexibility. Because calling KMS for every encryption or decryption operation could be costly and slow, AWS uses envelope encryption. In this model, KMS generates a smaller data key that encrypts the actual data, while the KMS customer master key encrypts the data key itself. This creates a layered system where bulk encryption happens locally with data keys, but the higher-level keys remain tightly controlled. Beginners should picture this like putting valuables in a small lockbox, then sealing that lockbox inside a larger safe. Even if the smaller box is exposed, without access to the safe, the contents remain secure. Access control in KMS involves multiple layers, including key policies, IAM policies, and grants. Key policies are attached to the key itself and establish who has primary authority. IAM policies are attached to users, groups, or roles, specifying who can call KMS actions. Grants provide temporary permissions for specific tasks without modifying the core policies. While this may feel complex, it allows precision in defining who can generate, encrypt, or decrypt with a given key. Beginners should think of this as different forms of authorization: permanent badges, visitor passes, and building rules, all working together to govern who can unlock what. Rotation is another important consideration. AWS managed keys are automatically rotated every year, while customer-managed keys can be set to rotate annually or manually rotated at custom intervals. Rotation ensures that even if a key is compromised, its useful life is limited. Think of it as periodically changing the combination to a safe. Even if someone overheard it last year, it won't work today. Beginners should understand that key rotation reduces long-term risk and is widely considered a compliance best practice, especially in regulated industries. Multi-region keys extend KMS functionality across global environments. Instead of maintaining separate keys in each AWS region, you can replicate keys securely to multiple regions. This is particularly valuable for disaster recovery, where workloads must fail over across regions, or for reducing latency in global applications. Beginners should imagine a master key duplicated securely into branch offices worldwide, ensuring that operations continue smoothly no matter where activity shifts. Multi-region keys simplify global consistency while still preserving strong cryptographic protections. One of the most valuable features of KMS is its service integrations. Many AWS services, including S3 storage, EBS block volumes, RDS relational databases, and EFS file systems, support encryption at rest directly through KMS. This means that when you enable encryption on these services, keys are automatically managed without custom code. For learners, this integration highlights AWS's philosophy. Rather than leaving encryption as an afterthought, it is built into the services you already use, reducing complexity and human error. Encryption in transit is equally vital, and AWS ensures this through TLS or Transport Layer Security. TLS secures communication between clients and services, preventing eavesdropping or tampering as data crosses networks. For example, when you connect to an S3 bucket or an API endpoint, TLS encrypts the session. Beginners should think of TLS as the sealed envelope around data traveling through the postal system. Even if someone intercepts the letter, the seal prevents them from reading it. In AWS, encryption in transit is expected as the default, not an optional add-on. To make TLS easier to manage, AWS offers Certificate Manager, or ACM. Certificates are digital credentials used in TLS to prove a server's identity and establish trust. ACM automates the issuance, renewal, and deployment of these certificates, eliminating the risk of expired or misconfigured certificates that could break security. Beginners should see this as an automatic passport office. It issues and renews identification for your websites and services so browsers trust them. This makes secure communication both simpler and more reliable. For organizations needing private certificate hierarchies, AWS Certificate Manager Private Certificate Authority provides a managed private CA. This lets companies issue internal certificates for devices, services, or users without relying on public certificate authorities. While more advanced, it enables enterprises to extend TLS protections into internal-only environments. Beginners should think of this as creating an internal DMV that issues licenses for employees rather than relying on the government. ACM PCA gives organizations the same benefits of certificate trust applied internally. Another critical best practice is enabling default encryption at the bucket, volume, or database level. This ensures that even if an engineer forgets to specify encryption, the system applies it automatically. It is a safeguard against human error, ensuring compliance is not optional but enforced. Beginners should imagine a rule in a warehouse that every box must be sealed before storage, no matter who delivers it. Default encryption enforces this consistency and reduces the chance of mistakes undermining security. Granular access control is essential for encryption operations. Permissions like KMS encrypt or KMS decrypt should follow the principle of least privilege, meaning users and services should have only the rights they absolutely need. Giving broad access to keys can undermine all other security controls, since encryption is only as strong as the access rules protecting it. Beginners should picture this as limiting who has keys to the filing cabinets. The fewer the people with access, the safer the documents remain. Least privilege ensures that keys don't become the weakest link. Finally, visibility is critical, and CloudTrail provides it for KMS activity. Every use of a key, whether to generate, encrypt, or decrypt, can be logged. This gives auditors and security teams confidence that keys are being used appropriately and allows rapid investigation if abuse occurs. For learners, this is like keeping a sign-in sheet at the vault. Not only is the door locked, but every entry is recorded, creating accountability. Logs complete the encryption story by ensuring that even the keys themselves cannot be used secretly. For more cyber-related content and books, please check out cyberauthor.me. Also, there are other prepcasts on cybersecurity and more at baremetalcyber.com. Amazon S3 provides multiple options for encrypting stored data, each with different trade-offs. Server-side encryption with Amazon S3 Managed Keys, or SSES3, is the simplest option. AWS handles everything, including key management, behind the scenes. Server-side encryption with KMS keys, or SSE KMS, provides tighter control, allowing you to use customer-managed keys in AWS KMS. This lets you define who can use the keys and audit every encryption and decryption event. Finally, server-side encryption with customer-provided keys, or SSEC, requires you to supply and manage the keys yourself. While powerful, SSEC demands strong operational discipline. For beginners, SSES3 is easiest. SSE-KMS balances ease and control, and SSEC is only for specialized cases. Amazon Elastic Block Store and its snapshots also integrate seamlessly with encryption. When you enable encryption on an EBS volume, any snapshots of that volume are encrypted automatically. Likewise, when you restore a snapshot, the new volume inherits encryption. This propagation ensures consistent protection throughout the data lifecycle. For learners, it is like sealing a container. Every copy you make of the container is sealed as well. This prevents accidental downgrading of security when data is moved between volumes and backups. Relational databases like Amazon RDS and Aurora also rely on KMS for encryption at rest. Enabling encryption on a database instance ensures that its underlying storage, automated backups, and snapshots are protected. Even read replicas inherit the encryption of the primary database. This guarantees that sensitive data cannot slip through unprotected paths. Beginners should understand that enabling encryption on databases is not only about security, but also about compliance. Many industry frameworks demand encryption of stored data, and AWS makes this requirement straightforward to implement. Other AWS services also provide built-in encryption. DynamoDB tables encrypt data at rest using AWS KMS by default, with no extra setup required. Amazon Elastic File System also supports encryption at rest and in transit, making it suitable for workloads that demand both scalability and compliance. For learners, the important lesson is that encryption is not limited to a few services. It is a design principle woven across the AWS ecosystem. No matter what type of storage you use, encryption is likely an option and often enabled by default. Client-side encryption takes this concept further by encrypting data before it ever reaches AWS. In this model, your applications handle encryption and decryption locally, and AWS only ever sees ciphertext. This provides maximum control but also maximum responsibility. You must manage keys securely, ensure applications implement encryption correctly, and handle rotation manually. Beginners should think of this as locking valuables in a strongbox before shipping them to a warehouse. The warehouse cannot open the box, but you must ensure the lock is strong and the keys are managed properly. To keep KMS and ACM secure in transit, organizations can use VPC endpoints. These endpoints allow private connections to encryption services without sending traffic over the public internet. Even though communications are already encrypted, private endpoints provide an extra layer of assurance and may be required in regulated industries. Beginners can think of this as building a private hallway directly into the bank's vault, avoiding the city streets entirely. It reduces exposure while still allowing full use of encryption services. Amazon Macie adds another dimension to the encryption and compliance story. Instead of managing keys, Macie helps identify sensitive data within S3 buckets. It uses machine learning to automatically detect patterns such as social security numbers, credit card details, or health records. By alerting you to the presence of this information, Macie guides where encryption and stricter access controls are most critical. Beginners should think of Macie as a data detective, shining a flashlight on the hidden valuables so they can be properly secured. Macie findings are categorized into classifications, often focused on personally identifiable information. For example, Macie might flag a dataset that contains passport numbers or banking details. These alerts help organizations prioritize protection efforts and support compliance requirements such as GDPR or HIPAA. For learners, this is like an airport scanner that automatically detects restricted items in luggage. By pairing Macie with encryption, organizations can ensure that sensitive data is not only identified, but also strongly protected. Like other AWS services, Macie integrates with Security Hub and EventBridge. This allows sensitive data findings to flow into central dashboards and automated workflows. For example, a Macie alert about exposed credit card data could trigger an EventBridge rule to lock down the affected bucket and notify security teams. Beginners should see this integration as an alarm system that not only sounds a bell, but also calls the fire department automatically. It ensures discovery of sensitive data leads directly to action. Key lifecycle management is another crucial aspect of KMS. When you schedule deletion of a customer-managed key, AWS enforces a recovery window, typically between 7 and 30 days. This safeguard prevents accidental loss of keys that could render critical data permanently unreadable. If deletion is canceled during the window, the key remains intact. Beginners should realize that encryption is unforgiving. If a key is destroyed without backups, the data it protected is gone forever. The recovery window is a safety net against irreversible mistakes. Cross-account encryption is often necessary in multi-account organizations. KMS supports this through carefully scoped key policies and grants. For example, a central security account might create a key, while application accounts are granted permission to use it for encryption. This ensures governance remains centralized while workloads remain agile. Beginners should picture this as a shared vault key managed at headquarters, but branch offices are permitted to unlock it under specific conditions. It balances organizational control with operational flexibility. Cost awareness is important when using KMS and Macie. KMS charges for API requests such as encryption, decryption, and key generation. Heavy use, particularly in high-throughput applications, can generate noticeable costs. Macie charges are based on the volume of data it analyzes in S3. Large, uncurated data lakes can become expensive to scan. Beginners should understand that while encryption and discovery are vital, they must be deployed thoughtfully. Just as insurance costs more if you cover every possible risk, KMS and Macie require planning to align protections with budget. For exams, learners should focus on conceptual distinctions between encryption tools. KMS is for centralized key management and integrates widely with AWS services. ACM manages TLS certificates for encryption in transit. Macie discovers and classifies sensitive data within S3. Together, they address different layers of the encryption and compliance puzzle. If a question asks about managing keys, the answer is KMS. If it asks about securing web traffic, ACM is the tool. If it asks about identifying personal data, Macie is the solution. Knowing which tool fits each purpose is key to exam success. In conclusion, encryption in AWS is about more than just turning on a checkbox. It involves managing keys with KMS, securing communication with ACM, and discovering sensitive information with Macie. Together, these services provide layered protection for confidentiality, integrity, and compliance. For learners, the main principle to remember is to encrypt by default, apply precise key policies, and use discovery tools to guide where additional safeguards are most needed. In a world where data is both valuable and vulnerable, AWS makes encryption practical, scalable, and effective for every workload. That concludes today's episode of the AWS Certified Cloud Practitioner Prepcast. Be sure to tune in for the next episode and visit us online at baremetalcyber.com or cyberauthor.me for more resources, including news, mailing lists, YouTube videos, podcasts, and much more.